So this is our lecture number 1, Boolean expression under Boolean function. A Boolean function is described by an algebraic expression called Boolean expression, which consists of binary variables, the constant 0 and constant 1, and the logic operation symbols. So this is what you call our function. It is function of your variable a, b, c, and d. And we have this equation that is e or b d bar or e b bar c, which we call this one as a function of your Boolean, and the other side is what you call your Boolean expression. So the left side of that equation represent for our output y. So if we have to write that one, it is equivalent to our y equivalent to this equation, which is our output. Boolean expression is a kind of mathematical function that produces a Boolean value. It is either a true, which is equivalent to 1, or a false, which is equivalent to 0. It is composed of combination of your Boolean constant. So we have two types of Boolean expression. We have the standard form or normal form and the canonical form. For a standard form, a Boolean variable in a true form or in the complemented form is called literal. If we have A, that is also E bar. If we have B, that is our true value. B bar is our complemented form. We have C or C bar, D or D bar. The Boolean product of two or more literals is called product term. So we have A, B, C, which is joined by an AND. We have E bar B, C, E, B bar C, and so on. If we have two or more literals combining together as a product, we call that one as product term, or combined by an AND, that is what you call your product term. A Boolean sum of two or more literals is called sum term. If you have two variables connected by an OR, then they are called the sum term. So we have this example, we have E or B or C. They are connected with an OR. We have E bar or B or C, and so on. So when a Boolean function appears as a sum of several product terms, it is said to be expressed in disjunctive standard form, or the standard sum of products, or SOP. So this is your example expression of your disjunctive standard form or and sum of products. When a Boolean function appears as a product of several sum terms, it is said to be expressed in conjunctive standard form or standard product of sum, or POS. So this is our sample of our POS. It is a sum. Then we have another sum, and another sum, and they are joined together by your operation AND. For the canonical form, each term of the Boolean function expressed either in SOP or POS has all the variables in it. So if every term in your expression, if we have 3 variables or 4 variables in that particular expression, each term must be expressed on those variables. So we have also the disjunctive canonical form or canonical sum of n terms. So this is an example of your canonical form where all the terms in your expression must be expressed on all the variables in your expression. So we have 3 variables, so therefore every terms in this expression has all those 3 variables. Another one is the conjunctive canonical form or canonical product of max term. So if we have 3 variables in your expression, all the terms in your expression must be expressed by the 3 variables. So we have this example. If we have to express the following expression into a canonical form. Sample number 1, we have y is equals to e bar b c or b bar c or a. Number 2 expression, we have quantity e or c and with your quantity b bar or c and with your c bar. So we begin with your first expression. So in your first expression, it has three variables. It is a, b, and c. For your first term, it has already three variables. So we have to do the second term, which is your bc. It has only two variables because it includes only b and c. So the lacking variable in that particular term is your character a. Character a can be expressed either a true value or a complemented one. If we have a complemented value of your a, we can represent or we can write the expression as a bar b bar c. If your e is at the true value, then we can write your expression as a b bar c. For your third term, it has only one variable because we have only a bar. So the lacking variable for that particular term is b and c. So b and c can either be represented by a complement or a true value. So we begin with that both variables are in the complemented form. So therefore, our expression must be a bar, b bar, c bar. One of your variable is in the complemented form. In this particular example, our c is in the complemented form, then our b is in the true form. So we have a bar, b, c bar. And if your b is complemented and your c in the true form, so we have a bar, b bar, c. And if both are in the true value, so we have a bar, b, c. So we have to write your expression. Then if there are expression or terms that have the same value, then you have to write it once. So in this example, for your first term, we have this one, e bar bc, and we have also e bar bc. For our first term, we have e bar bc, then under your third term, we have also e bar bc. We can write only once for that particular dual expression. So for your y, we have e bar bc, e bar b bar c, or e b bar c, or e bar b c bar, or e bar b bar c bar. For your second expression, it has the same three variables. So for the first term, there are only two variables. It is e and c. The lacking variable is b. We can express b in either true value or complemented one. If we have to express our b in a true value, so therefore we have e or b or c. In a complemented form, we can have a or b bar or c. For your second term, it has two variables, that is b bar and c. The lacking variable is a. We have a as a true value, then your expression is a or b bar or c. Or for a complemented form of your variable a, then we have a bar or b bar or c. The third term has one variable. We have c bar. The lacking variables are ab. So we have ab in a true form. So therefore, your expression must be a or b or c bar. One of its variable is in the complemented form. In this particular expression, we have b in the complemented form. So we have a or b bar or c, or your e is in the complemented form. Then we have e bar or b or c bar. And the last one, all variables are in the complemented form. So we have e bar or b bar or c bar. So the same, you have to write one time if there are dual value. So in this example, we have this E, B bar, C, or E or B bar or C is the same as your second term, this one. So we can write that as 1. So we have our expression as E or B or C for this one. Then we have another, then E, B, C bar, this for this one, and this and that one. So your the min term and max term, to make it more easier, is we have this truth table, how to represent your min terms and max terms. So if we have a variable ABC, then if you have to make a truth table of your variable ABC using your binary values, we have a values from 0 up to 7. In your min terms, it is the equivalent value of your ABC. For example, if we have 0 in your min terms, that is E bar. If we have 1 in your min term, that is equivalent to A. So it is the actual representation of your variable in your min terms to the value of that variable. But in your max term, it is an opposite. So to, to get your max term value of your 0, 0, 0, so we have your min term, it is E bar, that is B bar, and C bar. To make it a max term, we have to introduce a long bar, or we have to complement all these variables. Then after complementing the variables, we have to use your De Morgans to break this bar, and that will become your A double bar, or with B double bar, and your C double bar, applying double negative, so therefore it will become E or B or C. So in max term, the true value of your variable represent a 0. A complemented value of your max term represented a 1. So remember, this is positive value or no bar in your variable, but it represents 0, 0 in your input. So next, if we have to get all the min terms. So remember, we have these min terms. If we have to get all these min terms, then it is what you call your sum of, or canonical sum of min terms. So we can write this one from your ascending order from 0 up to 7 as a function of your ABC. Or we can have this one written in an alternative form using in your truth table. Remember that there is a letter M with subscript. So we have letter M in lowercase. This is your representation for your variable, or for your E bar, B bar, C bar. So this is your alternative canonical sum of min terms using the subscription of your min terms as lowercase m. And this is your symbolic canonical sum of product expression using the summation summation sign, that because it is a sum of the product. So we have a summation from 0, 1, 2, 3, 4, 5, 6, and 7. So the sigma sign indicates that the terms are min terms and that the function is a summation. And remember also, min term for each combination of the variables, this one, E bar, B bar, C bar, produces a value 1. Or this one, E bar, B bar, C bar, in his truth table, it is equivalent to 1. So and the function and taking the and of all those terms. If we have to get all those max term, we call that one as product of max term. So from 0 up to 7. So this is represent for 0, 0, 0, and this is represent for 1, 1, and 1. So this is what you call your canonical product of max terms. Then this is your alternative canonical product of max terms. A function of your EBC is represented by uppercase M. And your symbolic product of max term expression using a pi symbol. So pi symbol represent a max term that the function is a product. And also max term for each combination of the variables. So this one, E or B or C produces a zero in the function and then taking the OR of all those terms. So we have this example. If we have this example as a function y or an output y, then we can rearrange this expression in terms of an ascending order from 0 up to 5. So this is 1, 0, 1. It is equivalent to 5 as a function of your variable EBC because there are 3 variables in your y expression. Or it is equivalent to this alternative representation of your expression and a symbolic expression of your sum of products. So using the sigma sign. So if you have this one also, it is the product of sum. So we have to arrange that from lowest value to the highest value. And then take the alternative expression using the uppercase M and the symbolic expression using the pi. So given the symbolic expression, we can write a SOP or canonical sum of min terms and the canonical product of max term. So in this given symbolic expression, it is equivalent to your function EBC. We have 3 variables and we have the sign of sigma or summation, which is 1, 2, 3, and 7. So first we have to write your sum of product. So 1 represent for E bar B bar C, 2 represent for E bar B C bar, 3 represent for E bar B C, and 7 E B C. So this is our canonical sum of your min terms. Now, if we have to get the product of your max term, first we have to write the complement of your f. So the complement of your f is those values that are not found in your symbolic function. So those values that are not found in your symbolic function are 0, 4, 5, and 6, and they are your f bar. So if we have to write the expression of your function, complemented function of EBC, then therefore we have E bar B bar C bar for 0, or E B bar C bar for 4, or E B bar C for 5, and E B C bar. So there is a C bar because it is 6. Then we have to make this variable f into a positive, so we have to introduce another bar. If we introduce a bar in your left side, so we do also in your right side. So there is a bar here. Then applying your De Morgan's theorem as well as your Boolean algebra. So for this Boolean algebra, double negative, this will become an f. So this one, there is no more bar at this part because will become double bar. So we have this one, A bar or B bar or C bar with a bar on the upper side, so that it will become E double bar or B double bar or C double bar. Using double negative, we can write off all the bar. So we have now a true value of your A, B, and C. That is the same as this one, for this, and this one. Therefore, for the symbolic expression, since this is now a product of your sum, so we have to use pi. So that is the same, your f in your product of your max term is the same value of your complemented complemented value, this one f, which is equivalent to your sum of main terms but the complemented one. So that's all for our Boolean expression under Boolean function.